Example 3. Solve the inequality 5x plus 3 is greater than or equal to 2x squared. All right, so in solving this inequality, we are trying to find every single value of x that makes this a true statement, okay? So notice that there's an x squared involved. The highest power of x is 2. So this is a quadratic inequality. We're going to solve it by the graphical method. Okay, we are going to start by rewriting the inequality. Okay, there is nothing to multiply out here, but we do need to move everything to one side so that one side is 0. Okay, so we're starting with 5x plus 3 is greater than or equal to 2x squared. Okay, now remember what I told you. Okay, it is in your best interest to move everything over so that the x squared piece stays positive. Okay, well, here's the x squared piece. It's got a positive 2, and we'd like to keep it positive. So I'm going to move the 5x and the 3 to the right side. Okay, so 5x is positive, so I'm going to have to subtract it. Okay, whatever you do to one side, you have to do to the other. And then the 3 is also positive, so we need to subtract it from both sides. Okay, so 0 will be left on the left side. So we're going to have 0 is greater than or equal to 2x squared minus 5x minus 3. Okay, we do not flip the direction of the inequality symbol here. Remember, you only do that if you're multiplying or dividing by a negative. Okay, here we were just subtracting. All right, so this is what we're left with. One side is 0, but it is kind of funny looking because the 0 is on the left and the x's and the numbers are on the right. We can reorder it to what we're used to. So I am just going to switch the order. Okay, now you've got to be careful here when you rewrite it. So think of the inequality symbol as a shark's mouth. So think of the teeth. The teeth are pointed towards the 0. So if we switch the order here and I put the 2x squared minus 5x minus 3 on the left and the 0 on the right, the inequality symbol has to switch from greater than or equal to less than or equal to. That way the teeth, the shark mouth, is still pointed towards the 0. Okay, so be careful with that if you're reordering things. Okay, so going forward, this is the inequality I'm going to work with. 2x squared minus 5x minus 3 is less than or equal to 0. Okay, so this is what we need to focus on. Okay, the non-zero side becomes our f of x. Okay, so I'm going to write over here in red, f of x is going to be 2x squared minus 5x minus 3. Okay, we are going to graph this parabola. Okay, we need 2 pieces of information. Okay, it's just a rough sketch. Okay, we need to know whether it opens up or down. We need the x-intercepts. Okay, so if you look at this, the a value is 2, the b value is -5, the c value is -3. Since the a value is positive, the parabola opens up. Okay, so when we draw our rough sketch, we have to have a parabola that opens upward. Okay, so now we need to find the x-intercepts. Okay, so I'll put that in a different color here. Okay, so we're going to find the x-intercepts. Okay, so we're going to go to our function. Okay, we're working with this red function. Okay, and we're going to set y equal to 0. Okay, that's how you find x-intercepts. So we know y is the same thing as f of x. So we're going to get 0 is equal to 2x squared minus 5x minus 3. Okay, we need to solve this quadratic equation in order to get the x-intercepts. Okay, it is your call whether you factor or you use the quadratic formula. Okay, I will use the quadratic formula here just for practice. Okay, so again, we know our a, b, and c. We need to plug them into the quadratic formula, which is x is equal to -b plus or minus the square root of b squared minus 4 times a times c all over 2a. Okay, remember, if you don't you're not good at factoring, just use the quadratic formula, okay? The quadratic formula always works. There are certain situations where factoring does not, okay? So, you know, quadratic formula is always an option, okay? Let's plug into this. Okay, we're going to have negative b. Be careful here because the negative that I just highlighted is part of the formula. Okay, so we've got negative, and then we have to write down b. b is -5, so be careful there. Okay, plus or minus the square root of b squared, so -5 squared. Okay, you're squaring the -5, so it's -5 times itself, so that negative gets squared as well. Minus 4 times a times c. Everything is divided by 2a. Okay, this is how you plug into it. We need to simplify. Okay, all right, so let's see what happens here. We're going to get negative times negative is going to be +5 plus or minus. Underneath the square root, we're going to have -5 times -5, that's 25, minus, or minus times minus, we'll turn it positive over here. 4 times 2 is 8, times 3 is 24, all over 4. Okay, so this turns into, if you simplify what's under the square root, it's going to be 5 plus or minus the square root of 49. 25 plus 24 is 49, all over 4. Okay, we know the square root of 49, so we're going to get 5 plus or minus 7 over 4. Okay, that gives us 2 x-intercepts. Okay, so our first x-intercept, we're going to choose the plus sign in the middle. So 5 plus 7 over 4, that's going to be 12 over 4. That's going to be 3. Okay, and then the other x-intercept is you're going to get it by choosing the minus sign in the middle. So that's going to be 5 minus 7 over 4. So -2 over 4, which is -1/2 or -0.5, however you want to look at it. Okay, all right, so we've got our x-intercepts and we've got the fact that this parabola opens upward. Okay, so I'm going to go over here and draw a sketch of the parabola. Okay, all we need is the x-axis. You don't have to worry about the y-axis. Okay, you have 2 x-intercepts that you need to put down. There's one at -1/2 and one at +3. If you were walking along the x-axis, you would first encounter -1/2, and then later you would hit +3. Okay, we know that there are x-intercepts here, so the parabola is going to cross the x-axis at these 2 points, and it opens upward. Okay, so this is a rough sketch of the parabola here. Okay, so it looks like this. Okay, we do not care where the vertex is. Doesn't matter for this application. All right, so now that we've got the pretty picture of our graph, rough sketch, okay, we need to go back and focus on the inequality. Okay, the inequality that we are trying to solve, look in the box, it's 2x squared minus 5x minus 3 is less than or equal to 0. Okay, so 2x squared plus 3x, make sure I wrote it down right, plus, oh, oops, didn't. Okay, minus 5x minus 3 is less than or equal to 0. Okay, now remember, this 2x squared minus 5x minus 3, that's the parabola we just graphed. If you go back up here, okay, we called it f of x. Okay, that's the parabola. Okay, so if we translate this, this is saying f of x needs to be less than or equal to 0. F of x is the same thing as y. So basically, we need to look at our parabola and figure out where the y values are less than or equal to 0. Okay, so we are looking for negative y values, or since y can actually equal 0 because of the less than or equal to, y values can also be 0. Okay, so on any graph, where do you find negative y values? Well, below the x-axis. Okay, or yeah, below the x-axis. So this portion of the parabola is going to have negative y values. Okay, where do you find 0 y values? Well, on the x-axis itself. Okay, so the x-intercepts. Okay, remember this point is -1/2, 0 as an ordered pair. This point is 3, 0. Okay? So again, if we're looking at this parabola and we're trying to figure out what portions of it have negative y values or y values that are 0, that's what's been highlighted in purple. Okay? Any point below the x-axis has a negative y value. Any point on the x-axis, any x-intercept has a 0 y value. Okay, so we are ready to write down the solution to the inequality. Okay, we have to write down the x values over which this purple segment is happening. Okay, so here we go. Okay, if you look at this, again, you may want to draw some dividing lines. Okay, if you draw in vertical lines through the x-intercepts, okay, you can see that it divides your parabola up into 3 portions. You have the segment of the parabola less than x equals negative 1/2. You have the segment of the parabola between x equals negative 1/2 and x equals 3. And then you have the portion of the parabola where your x values are bigger than 3. So that's over here on the right. Okay. Well, the purple region we're interested in, where the negative y values live, are between the x values of negative 1/2 and positive 3. Okay, again, you have to use interval notation here. Okay, so every x value between negative 1/2 and positive 3 is going to have a negative y value. Okay, do you include the endpoints? Okay, the x-intercepts themselves? Well, yes, because they have 0 y values. Okay, again, the inequality symbol is, if you look in the box, remember, the original question has greater than or equal to, but we have transformed the inequality. We're working with the one in the box, the yellow one. Okay, the inequality symbol is less than or equal to 0. Okay, so we can equal 0, so we want to include the x-intercepts. Okay, this is the solution set. Okay, so I'll even write it here. Okay, what this means, okay, every x value between negative 1/2 and 3, including negative 1/2 and 3, makes the original inequality a true statement. Okay, so for example, x equals 0 is in this interval. It's a number between between negative 1/2 and positive 3. So if you plug it into the original inequality, you should get a true statement. Let's try it. 5 times 0 plus 3, is that bigger than or equal to 2 times 0 squared? Well, the left side turns into 3, the right side turns into 0. Boom, true statement. Okay? All right, let's try another one.